So today we're going to learn something called synthetic division. Synthetic, kind of like a synthetic fabric. It's not quite the real thing, but it still works. So synthetic division, these notes are going to go on page 74 whenever we're finished. Synthetic division is a simpler process for dividing a polynomial by a binomial. So it has a list of steps. The steps are really wordy, so I'm going to try and read what they say and do what they're doing so that you can kind of tell what's happening. Sorry, I moved my paper a bit. So the polynomial that we're dividing today at the beginning is 5x cubed minus 13x squared plus 10x minus 8, and we're dividing it by x minus 2. So step one is to put the terms of the dividend in descending order, and these are in descending order. We descend exponents from 3 to 2 to 1 to 0, so x to constant. Then we want to write the coefficients, the numbers in front of the terms of the dividend. We want to write these in a line, so 5, negative 13. Make sure you get the signs right. This is a positive 10. And this last one is a negative 8. You're going to write the constant r of the divisor, so this x minus 2, to the left. In this case, r is 2. Kind of think along the lines of, if this is my factor, what's the solution? So it's the opposite of this number that's being added or subtracted here. So the opposite of negative 2 is a positive 2. So I'm going to bring the first coefficient, which is 5, down. So 5 is going to come down here. I'm going to multiply this first coefficient by r. So 5 times 2 is 10, and I'm going to write that product underneath that second coefficient. And then I need to add that product in the second coefficient. So negative 13 plus 10 is negative 3. I'm going to do it again, multiply that sum, that negative 3, by 2. Negative 3 times 2 is negative 6, and I'm going to write it under the next coefficient. Add up the 10 and the negative 6, which is 4. I'm going to do it again. 4 times 2 is 8. And I'm going to add up those last two. Negative 8 plus 8 is 0. The numbers along the bottom row are the coefficients of the quotient, so your answer. You're going to start with the power of x that's 1 less than the degree that you started with in the dividend. So the degree we started with in the dividend was a degree 3, so here we're going to start with a degree 2. Thus the quotient is 5x to the power of 2, or x squared, minus 3x plus 4. And the 0 is my remainder, so that means there is no remainder, and this is my answer. So I'm going to open this up and go to the next page. Okay, so examples 2 and 3 say divide. Use synthetic division to find each quotient. So I'm going to take the dividend, the coefficients of the dividend, and I'm going to write them out in a row, making sure that I don't skip any power, so all the powers have to be included. I've got 2x cubed plus 3x squared minus 4x plus 15. And the r value is kind of the opposite of what's in here. So instead of a positive 3, I'm going to write a negative 3 out to the side. First thing I do is bring that first coefficient down. And I start to multiply. So 2 times negative 3 is negative 6. 3 plus negative 6 is negative 3. Negative 3 times negative 3 is 9. Negative 4 plus 9 is 5. 5 times negative 3 is negative 15. And 15 minus 15 is 0. And when I write my quotient, my answer, I'm going to start with the term that has 1 less power than the one that I started with in the dividend. So I have a x cubed. That means that my first term here is going to be an x squared. And these are my coefficients. 2x squared minus 3x plus 5 with no remainder. This is my answer. So I want you to pause the video and try example 3 on your own. I'm going to give you some time to do that, so pause, and then you can check your work with mine. You want to be sure that you've set up your problem correctly, so make sure that the coefficients of your dividend are all correct with the right sign, so 3, -8, 11, and -14. My R value should be the opposite of whatever is inside of those small parentheses, the x minus 2. So I wrote -2 for my R value. That's not correct because the opposite of -2 is a +2. So make sure that you are writing the opposite of what is inside of these parentheses. Bring down your first coefficient and continue to multiply by R, write the product, and combine. Multiply by R, write the product, and combine. Multiply by R, write the product, and combine. So finish your problem. Your final answer should look like this. Remember that the quotient started out with a 3x cubed, so 3 was the highest power. That means that in my answer, 2 is going to be my highest power because I want to start with 1 less than the highest power that's in my dividend. So we're going to move to example 4. Example 4, I want you to try completely on your own, so pause the video, and then when you start the video back up, the work and the answer will be there, and we're going to discuss the remainder in this problem. So pause the video and try number 4. So in this problem, our coefficients for the quotient were 3, -7, 9, and -10. If you start by writing the first term as an x squared term, then you end up with -10 not giving you a nice place to be. That's because -10 is your remainder. So remember whenever we used long division that we wrote our remainder over what we were dividing by, so the x plus 1. And this is your final answer for number 4. Sorry, I know it's all over the place. I have it taped and I'm doing it with one hand. So let's look at number 5. Number 5 is a different looking problem because it only has 2 terms, but the biggest exponent is a 3. So that means we're missing terms, kind of like in yesterday's notes when we did polynomial long division and we said that all of the variables, all of the exponents need to be represented. That's something that we need to do here as well. So we start out with x cubed. The next thing that we should have is an x squared term, but there isn't one here. So you're going to have to put plus 0x squared. The next thing we need is an x term, but there isn't one here, so we put 0 x's. And then the next thing is a constant term, and so we do have a 27. And this lets you see all of the coefficients that should be in your synthetic division problem. So the coefficient of x cubed is really that 1 that's invisible, so 1, a 0, a 0, a 27. And the opposite of a +3 is a -3, so that's my R value. I'm going to bring down my first coefficient. And I start multiplication. So 1 times -3 is -3. I sum my 2 values. -3 times -3 is +9. I sum my 2 values. 9 times -3 is -27. I sum my 2 values. Look, I'm going to have a remainder of 0. My problem starts out with an x cubed, which means my answer starts out with an x squared. That's 1x squared minus 3x plus 9 with no remainder. So go ahead and flip to the next page. We're going to do one more type of thing with synthetic division, and then you can start working on your homework. Okay, so the next thing we're going to try is factoring using synthetic division. Remember that factoring means that you want to get things that are in parentheses. You want to break up your polynomial to be things in parentheses. And so when you do synthetic division, what you end up with is an answer that if you multiplied it back by the smaller binomial, you would end up with the larger polynomial. For example, on number 5, the problem was x cubed plus 27. Oops, sorry. x cubed plus 27 divided by x plus 3. And what we got was x squared minus 3x plus 9. Whoops. So I could rewrite this to say that x plus 3 times my answer, x squared minus 3x plus 9, is equal to the larger polynomial, the x cubed plus 27. So the factors of x cubed plus 27 are x plus 3 and x squared plus 3x minus 9. It actually happens to be the sum of cubes. So if you want to check sum of cubes with the formula, with x cubed plus 27, you end up with this. So what we're going to try and do is we're going to try to put together the factors that create the larger polynomial. So in example 6, here's the larger polynomial. I want to divide it by the x plus 1 that you see. So we're going to do just synthetic division like we've been doing the whole class period so far. My coefficient is 1, 2, -5, and -6. And the opposite of plus 1 is minus 1. So that's my r value. I'm going to bring down my first coefficient. And I do synthetic division. So 1 times -1 is -1. 2 minus 1 is 1. 1 times -1 is -1. -5 minus 1 is -6. -6 times -1 is +6. And -6 plus 6 is 0. So that's looking good. I'm going to write my answer, but I'm going to write it in parentheses. So just under x cubed, the next lowest term should be an x squared term. So 1x squared plus 1x minus 6. And if I multiply that by x plus 1, I should get my larger polynomial back. But I notice that this is a trinomial, and this trinomial is something that I've seen before, and I can factor it using magic numbers. So I need two numbers that multiply to be 1 times -6, so -6, and two numbers that add to be that middle term, that 1. Can you find the magic numbers? The magic numbers are -2 and 3. So I can break this factor up into two smaller factors. I can break it up into x minus 2 from that magic number, and x plus 3 from that magic number, and x plus 1 from the original problem. And these three factors multiplied together will give me the larger polynomial. So what I'd like for you to do on example 7 is try it. I want you to write down the coefficients. I want you to write down the r value. I want you to try the synthetic division and see if you can get the factors and break it up even more. So pause the video and try example 7. If you need to check your synthetic division, it's shown on the screen. So pause the video, check your synthetic division, and then try the next step, which is to write the factors. So you can check the original factors on the screen before you break it up even more. Notice that the 0x term in the middle can go away, and you're left with x squared minus 9 as that quotient. I also noticed that x squared minus 9 is a difference of squares, so you might want to take out your formula chart and look up difference of squares, because you can take x squared minus 9 and factor it even further with a formula. So pause the video, try to get the final factored form, and then check. On the screen, you'll see the final factored form using the difference of squares formula. So you can check that. This gets glued into page 74 of your notebook, but please don't glue it today because I don't want the glue out and about in the classroom. I'd like it to stay where it is. You need to get the homework sheet from the substitute, so please ask for that homework sheet if you haven't received it already. And then if you plan on retesting after school, that's going to be in Miss Purdy's room, so please get there on time. Y'all have a great day.